Hi there, I'm Krina Patel and I will be talking about the drug penicillin today. This is a class assignment for Chemistry 4201 and this is for Dr. Manning's class and I hope you enjoyed the video. So I will be covering the following topics. What is penicillin? The discovery of penicillin, the production and its medical uses, and the mechanism of action. What is penicillin? Penicillin, sometimes abbreviated as PCN or PEN, is a group of antibiotics derived from Penicillium fungi. Penicillins are used to treat infections caused by bacteria. They work by killing the bacteria or preventing their growth. Penicillin antibiotics were among the first drugs to be effective against many previously serious diseases such as bacterial infections. There are several kinds of penicillins. Each is used to treat different kinds of infection. One kind of penicillin usually may not be used in place of another.
The discovery of penicillin, one of the world's first antibiotics, makes a true turning point in human history. Penicillin was discovered in London in September of 1928 by Dr. Alexander Fleming, the bacteriologist at St. Mary's Hospital. Upon the examination of some of the staphylococcus, Dr. Fleming noted that a mold called Penicillium notatum had contaminated his petri dishes. After carefully placing the dishes under his microscope, he was amazed to find that the mold prevented the normal growth of the staphylococci. However, it took Fleming a few more weeks to grow enough of the mold so that he can actually confirm his findings. His conclusions turned out to be phenomenal. There was some factor in the penicillium mold that not only inhibited the growth of the bacteria, but more important, might be harnessed or to combat infectious disease. However, though Fleming was credited with the discovery, it was over a decade before someone else turned penicillin into the miracle drug for the 20th century. In 1940, the second year of World War II, two scientists at Oxford University were researching promising projects in bacteriology that could possibly be enhanced or continued with chemistry. Australian Howard Florey and German refugee Ernest Chain began working with penicillin. Using new chemical techniques, they were able to produce a brown powder that kept its antibacterial powder for longer than a few days. They experimented with the powder and found it to be safe. Needing the new drug immediately for the war front, mass production started quickly. The availability of penicillin during World War II saved many lives that otherwise would have been lost due to bacterial infection in even minor wounds. Though Fleming discovered penicillin, it took Florey and Chain to make it a usable product. Penicillin production emerged as an industry as a direct result of World War II. During the war, there was an abundance of jobs available in the U.S. on the home front. The War Production Board was founded to monitor job distribution and production. Penicillin was produced in huge quantities during the war and the industry prospered. In July 1943, the War Production Board drew up a plan for the mass distribution of penicillin. Stocks to Allied troops fighting in Europe. At the time of this plan, 425 million units per year were being produced. As a direct result of the war and the War Production Board, by June 1945, over 646 billion units per year were being produced. There are two different categories of penicillin. Biosynthetic penicillin is natural penicillin that is harvested from the mold itself through fermentation. The other form of penicillin is known as semi-synthetic. There are all kinds of what are called semi-synthetic derivation of penicillin, like ampicillin, penicillin V, carbonicillin, oxacillin, methicillin, and many more. These compounds consist of the basic penicillin structure, but have been purposefully and chemically modified by removing the acyl group to leave 6-amino penicillinic acid and then adding the acyl groups that produce new properties. These modern semi-synthetic penicillins have various specific different properties. There are three main instances where penicillin would be used. These are to help fight off a bacterial infection, to prevent infection for someone with a weakened immune system due to existing illness or conditions, or to give someone immune system help if they're undergoing treatment which could leave them vulnerable to infections. Just like any other medication or drugs, penicillin also has many side effects. Um, to name few, serious side effects include diarrhea that is watery or bloody, fever, chills, body aches, flu symptoms, easy bruising or bleeding, unusual weaknesses, urinating less than usual or not at all, severe skin rash, itching or peeling, agitation, confusion, unusual thoughts or behavior, or seizure. Beta-lactam antibiotics work by inhibiting the formation of peptidoglycan cross-links in the bacterial cell wall. The beta-lactam moiety functional group of penicillin binds to the enzyme that links the peptidoglycan molecules in bacteria, which weakens the cell wall of the bacterium. In other words, the antibiotic causes cytocell or death to due to osmotic pressure. In addition, the buildup of peptidoglycan precursors triggers the activation of bacterial cell wall hydrolase and autolysin, which further digest the bacteria's existing peptidoglycan. The gram-positive bacteria are called the protoplast when they lose their cell wall. Gram-negative bacteria do not lose their cell wall completely and are called spheroplasts after treatment with penicillin. Penicillin shows a synergistic effect with aminoglycosides, since the inhibition of peptidoglycan synthesis allows aminoglycosides to penetrate the bacterial cell wall more easily, allowing its disruption of bacterial protein synthesis within the cell. This results in a lowered MBC for susceptible organisms. Penicillins, like other beta-lactam antibiotics, block not only the division of bacteria, including cyanobacteria, but also the division of cyanelles, the photosynthetic organelles of the glaucophytes, and the division of chloroplast of virophytes. In contrast, they have no effect on the plastids of the highly developed vascular plants. This supports the endosymbiotic theory of the evolution of plastid division in land plants. So I covered the the overview of penicillin, what it is, and the discovery of penicillin, the production of it, the side effect of this drug, the mechanism, and I listed the details of it. So thank you for watching this video.